So today in the shop, we're going to be documenting the disassembly on this Home Light small two-stroke engine. This would be for a string trimmer. How we take this apart will be very similar for no matter what make and model string trimmer you get. What we'll start with though is an overall inspection of it and why I think this ended up at my workshop, not necessarily needing an engine rebuild, but needing some fuel system work. Come take a look. Okay, so if we look at this engine, we've cleaned it up a little bit, and I've also disassembled it from the string trimmer attachment, which essentially had a pinch bolt where it would squeeze on right there, and the shaft plugged into here, and then there's a cable that comes out of the engine. There's a centrifugal clutch here. The cable goes out down to the string trimmer assembly. So because the kill switch is on the engine right here, I didn't even have to take apart any wires or anything. I just had to loosen the pinch bolt, and that string trimmer head and shaft assembly just slid right out of the engine. So we can see the kill buttons on the engine, the choke, all those controls are right on this engine. And like I said, we've cleaned it up considerably so that it would show well on the video today. Looking at this engine, I'm going to say that a good thorough visual inspection really probably will determine what went wrong with it, because if I start to look at the back side of it and I look at these fuel lines, I notice that they're all rotted and eaten up. Today's gas has a high content of alcohol. The fuel lines here and the diaphragms and gaskets inside the carburetor, they don't like that alcohol in the fuel. So you're likely to get 4, 5, maybe 6 years before they need to be replaced. I bet this engine doesn't have really too many problems with it other than the fuel lines and filters should be changed and maybe the carburetor rebuilt and replaced. Let's do a few more inspections though. I'm going to take off the air filter assembly, and when I do that, I always like to look inside the air filter to see if any dirt and debris was getting underneath the filter. Now, on the outside of the filter, it looks pretty clean. But what we really care about is the inside of the filter. And if I take my finger and wipe around here, yeah, there's some fuel residue, but I'm not feeling a lot of dirt and debris. I'll take a white towel here in a minute and wipe around. I think the filter was likely doing a good job filtering out the dirt in this engine, and this engine probably has decent compression, which leads me to say I need to do a quick compression check, and I'll give you a tip on that right now. So for the compression check, on other videos I've documented how to properly do a compression test, but here's a quick tip on a handheld motor like this, whether it's a string trimmer or a chainsaw, use the weight of the engine. If I can hold the rope and the engine maintains its position, it doesn't just suck down to the bottom with gravity. If I can suck the rope in and it holds itself pretty good, like this one's doing, that's a great indication for you that this thing has decent compression. So again, I'm thinking that the only problem with this engine is not that it doesn't have compression, because it does. The problem is the fuel lines and probably the carburetor itself have been eaten up over the years of sitting with today's fuel in there. We're going to go ahead and proceed with our disassembly, and we'll see if we back up that diagnosis. Okay, so we're going to take off this front cover of the engine. Now it has these fasteners that are a combination flathead screwdriver or Torx socket. I could use a flathead like this and unscrew all these fasteners. The flathead wants to slip out, and quite frankly it's a little frustrating. What I've chosen to use is a Torx socket. It's got this star on the end, and that'll center a little easier and allow me to take these out rather quickly. Here's the cover with our pull start mechanism. Now we can see the flywheel of the engine, and the ignition coil magneto assembly. Now we're going to take off the back cover. Uses 4 of those same fasteners. This back cover also has a muffler guard on there, so now I can take the muffler off if I wanted to. But what's amazing is that this back cover has a gasket on it, and it actually also serves to view the crankcase of the engine. So I'm looking inside the engine at the bottom of the connecting rod and counterweights inside there. They don't actually support the crankshaft on 2 sides on these very lightweight string trimmer type engines. With this back cover removed, I can now disconnect the fuel lines and pull off the gas tank. Now to better support the crankshaft, I'll probably put this back cover on in a minute as I go to remove the flywheel. But what I wanted to note is that taking off the exhaust and intake right now is relatively easy. In fact, if I take off the exhaust, it's a great way for me to evaluate the condition of the engine, because I can look right through the exhaust port and look at the side of the piston and see if it has any scoring on it. By the way, we didn't mention this earlier, this is a 2-stroke engine, and this happens to be a piston port 2-stroke, as I have a port going in for the intake and a port going there for the exhaust. There's no reed valves on this engine, so this is your classic piston port 2-stroke. Okay, 2 quick bolts and I can remove the exhaust. Now this isn't a real high performance 2-stroke, so it's not like it has an expansion chamber or something like you might find on a motorcycle engine. The exhaust does need to muffle the noise. It also needs to prevent any sparks from exiting the engine. So you can see these baffles and stuff in here are designed to make sure that no hot sparks from the engine are allowed to exit and go out the exhaust, which could likely cause a fire. I got one other thing I'd like to show you, and that is that there's a wire screen in the exhaust. This wire screen is part of your spark arresting mechanism, and because 2-strokes burn oil, if you have something with a lot of hours on it that has a lot of power, it could be that this screen is totally clogged up with oil and you have a restricted exhaust. You're just not getting the exhaust flow out of there. So part of your maintenance schedule on a 2-stroke really is removing the exhaust system and cleaning out this spark arrestor screen. This one looks pretty good. Again, I don't think there's a lot of hours on this engine. Now that we have the exhaust out, we can really look down inside the cylinder and look at the side of the piston to help us determine what condition the cylinder's in. If I see a lot of scoring or discoloration on the side of the piston, that's a great sign for me that this engine is on its way out, right? It needs a new piston and ring installed, or it needs to be replaced. What I'm going to do now is I'm actually going to put that back cover back on the engine to help support the back crankcase of the engine, because I need to break the flywheel loose. So I have a professional piston stop right here. This one's made out of brass. They also make these out of plastic as well, but we're going to use a piece of rope to act as a piston stop in our engine. You could also use line from your string trimmer. You just need something that you can fish in and out of the spark plug hole that will stop the piston from getting all the way to top dead center to hold the engine in position. Okay, so I'm going to show you another method to remove this flywheel nut if you do not have an electric impact or an air impact, just using hand tools. Of course, the problem with hand tools is if I try to turn this, the motor just spins, right? So I need to make a piston stop. So I have a piece of rope here. I've melted the ends of it, and I'm going to put the piston at the bottom of its stroke or bottom dead center, and then I'm going to fill through the spark plug hole the cylinder with that rope. I'll get in as much as I can, and then I'll bring the engine up. At this point, the engine doesn't want to turn because it's hitting the rope, and the rope's nice and soft, so it gives it a nice piston stop material to go against. And I can then take this nut here and loosen it. And there we go. Now, a lot of small trimmer type engines will have a clutch mechanism here. So you may not be able to use a ratchet in a socket. You may have to use a wrench on the end of the clutch and use the wrench to spin the motor free and break this nut loose. So a couple different varieties. This is an older engine. There's no clutch assembly on it, as we found. Once I get this guy off of there, you can see that we'll have just the end of the crankshaft in here with its flywheel key assembly, and there's no clutch mechanism on this engine. Okay, so taking off the flywheel assembly, these little teeth here are for the pull start assembly. They're what engage the pull starter. I need to get the ignition coil out of the way. Here's the wire to the kill switch. I'll disconnect him and pull him out of the way. I'm also going to take out the spark plug. So the spark plug's removed. Two more Torx bits. Hold my ignition coil in place. Remember that ignition coil has a set gap to the flywheel, so if we're putting this back together, we have to set that. It's usually somewhere between 20 and 30 thousandths. You could set that with a piece of cardstock. All right, now we have all those parts removed. There's no spark plug in there, so that's why there's no compression. We're ready to take this flywheel off. We need to get a long socket to take the flywheel nut off of the engine. Okay, so what I'm going to do to take the flywheel nut off is I'm going to hold the flywheel and hit with my impact gun. 13 millimeter on this one. And that spins right off. Now, I could have also made a piston stop and broken it off by hand if I needed to. Now I have my flywheel and he's kind of stuck in place, so we're going to go back to the strategy that we had before that we used on other engines, where we're going to tap on the crankshaft to get the flywheel off the engine because of that tapered seat. So I'm actually going to thread this guy back on there. Back them off just a little bit. And I'm going to get a brass hammer in this case, because I really don't want to deface that at all, and tap on this crankshaft while I'm lifting up. So I'm going to use a little pry bar here just to provide some upward movement so I'm not getting my hands in the way of the frame. But again, you could pull up on it with your hand. You could use a flathead screwdriver. Just be careful not to crack the case, right? The case is aluminum. It's a pretty lightweight metal. So we got that upward pressure, and now we're going to tap on it with the brass hammer. And that popped up. So the flywheel will come right off of there. All right, we've removed the flywheel, and I showed you a couple different methods to do that. This engine here is now ready for some serious disassembly. It should go apart rather quickly. I need to take the flywheel key out before I forget. I'll do that with some needle nose pliers. And if this is difficult to remove like that one is, some diagonal cutting pliers often works really well to remove these stubborn flywheel keys. If you can get it in there, you can really just bite down on the... So I had to actually pry up on this one a little bit. Now we'll see if we can get it out. There we go. persistence pays off. We got the flywheel key out of there. I'll put him in my magnetic parts dish so I don't lose it. And sometimes something that should be relatively easy wants to fight you. That's okay. All right, so we have that ready to come apart there. I need to take the carburetor off, so I'm going to remove these two Torx head screws and do that right now. Keep in mind, I think really what we had wrong with this engine was carburetor issues. And I think what I'm going to do, when I'm all done with this video, is put this thing back together and save it for class, because this would be a great engine for disassembly, reassembly, and some running tests on the engine. So, pull starter assembly, I'm sorry, not the pull starter, but the ignition kill was part of the air cleaner assembly, which was pretty neat. This air cleaner, like we showed you before, didn't have a bunch of dirt on the inside, and that's why the inside of the engine looks so good. But we definitely had some broken fuel lines on here. We pulled those bolts out. The diaphragm style carburetor with primer bulb comes right off. You can see the two mixture screws with their limiter caps in place. So that pulls right out of there. This lever here is for the choke valve. So I might be able to just ultrasonic clean that carburetor and get them back in service. Or I might need to rebuild it with the diaphragm kit. And I could probably buy this whole Walbro carburetor for probably $10, $15. All right, now we're going to take off the intake insulator. This intake insulator is there for a couple of reasons. One, it helps prevent heat from reaching the carburetor so much, which helps keep the fuel cooler in the carburetor. So that's important. Two, it also provides me a little pulse port. So it may be difficult to see, but there's a little tiny hole right here in the carburetor base plate here, and that hole lines up with this hole in the engine, and that hole goes to the crankcase, and as the piston's moving up and down, that has a crank that delivers crankcase pulsations from the crankcase through this plate and ultimately to the fuel pump diaphragm inside the carburetor. Because remember, a diaphragm style carburetor is not just a carburetor, it's also a fuel pump mechanism in here, so we can operate this engine at any angle and it will stay running. So it's a fuel pump and a carburetor all in one little package here, but it needs a pressure pulsation to pump that diaphragm back and forth for that fuel diagram. So that pressure port there lines up with this, which ultimately moves the diaphragm inside the carburetor and pumps fuel to the engine. So we have the carburetor removed. At this point, we can pull this back plate off again and slide off the cylinder. There was a gasket on that earlier. When I reinstalled it to remove the flywheel, I didn't put the gasket back on. So now I have 4 screws that put the cylinder back on the engine, or secure it to the bottom crankcase of the engine. These 4 screws, actually, now that I look at it, it's only 3 screws on this one. They must have saved 2 cents per engine by making it only 3 screws. But these 3 screws in this case hold this guy down on there. What I was going to say is do not spin the cylinder off of the piston, because you're likely to hit a port and you can break your piston rings. So I need a little bit more loosening at this point. There we go. That guy slid right off of there. I can see the piston and ring assembly. I'm going to position him up. I can slide him off the bottom of the crankshaft. I'll take those bolts, put them in my parts dish again so I don't lose them. A lot of these are different lengths and different threads. I've already removed the flywheel key, so I should be able to push the crankshaft out with some moderate pressure. But really what I want to focus on is that cylinder. So let's do that next. Okay, so we have our crankcase here. It still has the crankshaft in it. We have our cylinder, and this is not just the cylinder, but it's also the cylinder head. It's all put together as one piece in these less expensive two-stroke engines. It makes it easier to manufacture and less expensive to manufacture that way. So I want to take a look at this piston assembly, and I'm going to pull off the piston ring. What you'll notice is that there is no oil control ring. There's not even two rings on this particular piston. Now, some two-stroke engines, you do find two piston rings, but you know, you have a primary compression ring and secondary. But a lot of high-performance two-stroke engines, you don't have a piston ring. I suspect that this one, though, the second ring simply is not there just for cost, saving money on the build. This one's also very unique. As I look at this piston, I don't see a piston ring locating pin. Now, let me explain what I mean here. Most four-cycle engines, the piston rings normally rotate slowly as the engine is in operation. And they do that, it just natural harmonics of the engine cause the engine rings to vibrate around. And that has nice even wear on the ring. But in a two-stroke engine, you have ports in the cylinders there. So if I put that above the intake port, you can see inside the cylinder. If I put it the exhaust port, again, you can see inside the cylinder. There's ports in the ring gap. If we're not careful, it can get caught on one of those ports and do a lot of damage. And to show you what I mean, I brought over a couple different pistons from other engines. So let me move this out of the way. Here's a small outdoor power equipment piston. This one, you notice it's got two ring grooves, right? And if I look right there, what I'll notice is that there is a pin right here that prevents the piston ring from rotating. And if I look on the other side, there's a pin for that ring. Now these rings somehow popped out of their groove, and look at the damage that ensued on this engine. Let's look at a couple more pistons. I have two examples here. This would be a 100cc, 100 cubic centimeter engine, and this is out of an 80cc shifter engine. So again, both of these, they're more of a high performance engine. They only use one piston ring. This one, you can see the ring moved. It caught one of those ports and it pushed the ring down and really destroyed the ring land of that ring is messed up real bad on this particular piston. Also notice it says IN on one side. That stands for intake. So this side faces the intake. You'll notice it's got a cutout right here because that's a reed valve engine that piston went to. This piston here doesn't have IN on one side. It's hard to see it now, but what this piston had was an arrow, and that arrow faced the exhaust port. But again, piston ring locating pin right here. So if I go with my screwdriver, it gets caught right there, so the piston ring does not rotate around. This is a piston port, so you'll see that the base of the piston is the same on both sides. It has some scuffing there. This particular one ran lean and caused some problems. Now, let me show you another 80cc piston. This one ran really lean. So, see how there's a hole in the piston? That's not supposed to be there. That hole was caused by an incorrect carburetor main jet. This particular engine had really big jets for the low speed or pilot circuit, but the main metering was way too lean. And so if you drove it around, it accelerated off the line really hard, And as long as you weren't wide open throttle for too long, it was fine. Well, if you've ever driven an 80cc shifter cart, they're pretty darn fast. And so most people would get in it, scare themselves, let off the throttle. When we finally got it out on a proper karting track and really went wide open throttle for a long period of time, boom, we windowed the piston because it was jetted too lean, and that hot air-fuel mixture created really hot combustion. That lean air-fuel mixture created really hot combustion, burned a hole right through the piston top in short order. So wrong jets can cause a lot of damage in an engine very quickly. But again, if you look at this particular engine, piston from this engine, you'll notice that, well, these rings are actually kind of stuck in there, but it has a piston ring locating pin on there. So with all these pistons, I probably should try to find the markings so you can see the orientation of them. I've cleaned the top of the piston, and you can just barely make out, even with all my cleaning, that there's a little tiny arrow right here on the piston. That arrow would face the exhaust port, and that's how you would orient this piston in the cylinder. Really important when you're working on engines that you look for arrows and markings so you know the right way to put in the piston. A lot of times these pistons are not centered in the wrist pin bore, so they're offset to reduce piston slap and drag in the engine. And if you do not orient them correctly, you're going to create yourself all kinds of problems. This would have been looking through the exhaust port. We would have seen this side of the piston in this engine. And like I've told you before, looking through the exhaust port is a great way to figure out the condition of a two-stroke. If it looks like this, it needs a new piston ring at the very least. Let's go back to our two-cycle trimmer engine. So as I look at the cylinder on this engine, again, it's a piston port two-stroke. I got a port on the intake. Here's that intake pulse port that goes down through that hole right there to the crankcase for the diaphragm of the carburetor. Here's the exhaust port. You'll notice the exhaust port is slightly higher than the intake port, and that's how the two-stroke works essentially, is that it draws in air-fuel mixture into the bottom of the engine, and it transfers air-fuel mixture to the top piston by these sides. So those side cutouts in the sides of the cylinders right there and there, those are our transfer ports. So when you label your two-stroke engine, if you're doing an engine labeling activity, make sure you label all the different ports. So I have an intake port, I have an exhaust port that has a little window set up there or exhaust bridge on it, and it's got two transfer ports here on the sides. I suspect what they did to prevent the need for a piston ring locator pin is they put that bridge on the exhaust, and they kept the ports all small enough so even if the ring rotated, it would not cause damage in this engine. And remember, in this particular cylinder, the cylinder head and cylinder are all one piece. So, intake port, exhaust port, transfer ports on the sides of the cylinder walls. And you'll see different shapes, sizes of transfer ports. These are open transfer ports. On a more elaborate engine, a more high-performance engine, you're likely to see closed transfer ports. So the ports on the side, again, look like little windows. But that's the various ports on the two-stroke cycle engine. Now let's focus our attention on the crankcase. So for the crankcase, we have to get our crankshaft out of this engine. Now it's on a roller bearing, and this bearing is an interference fit in here, so we're going to have to put it on the press. Before we do that though, we want to make sure we clean any rust or debris off of this crankshaft snout so he presses out of that bearing nice and smooth. So I've cleaned the end of the crankshaft. I'm going to hit the end of the crankshaft with just a little bit of penetrating oil. We'll let that oil soak in. And my preferred tool to use here would actually be to take this crankcase over to the press and press it out. However, for purposes of our video, I'm going to use some hammers like you would likely use at home. You just have to be careful not to mess up the bearing. And so I'm going to use two hammers in tandem. I have a brass hammer here, but I really want to not mess up on those threads. So I'm going to use the brass hammer, but I'm actually going to set that brass hammer right up against the end of the crankshaft and tap on it with a baby sledge. There we go. Crankshaft's out. I had to put some blocks of wood on there to lift up the crankshaft, and I had to make sure that the crankshaft was positioned correctly inside the crankcase. You can see at first it wasn't positioned perfectly, and it was actually nicking the side of the crankcase. I had to move it to get it in the proper orientation for removal. We have our crankcase separated here. I've done some cleaning on it. The crankshaft is removed. We'll set those aside. There's actually one more piece that I would like to disassemble for you, and that's taking the piston off the connecting rod. Now, it's very difficult to see, but there are some small clips on the wrist pin. And I'm going to use this little pry tool to pull those clips out. This little pick, I should be able to get in there and just kind of rotate it around, push the wrist pin back to the other side. There's just a little bit of play. And these things do like to fly all over the shop, just like that one just did. But I got that guy out of there. Now I can push the wrist pin out very carefully. Now what I've done is I'll take a bolt here just to give myself something to help me push. So I get it most of the way out. I can then take that apart. There's just a little bit of interference there. So there's my wrist pin, piston, connecting rod, and you can see that there's my upper rod bearing, which is a needle bearing, and my wrist pin bearing and my lower rod bearing. They're both needle bearings on this engine. I do have to talk about the wrist pin clips for a minute that I took out. These clips hold the wrist pin in. This is a full floating pin design that you find on two-stroke engines, and a lot of your small engines for that matter. These clips should always be replaced. You can see how it was difficult for me to pull that clip out of there, and how once I got it out, it wanted to fly across the shop anyways. There's that clip right there. If one of those clips comes out when the engine's running, it's catastrophic failure. It scores up the cylinder. It really damages a lot of components and can ruin an engine. So anytime you're rebuilding a two-stroke, and that would usually not be a string trimmer like this, but it would be a two-stroke like on a motorcycle, right? Maybe an 80 or a 125. Or always replace the wrist pin clips here on your rebuild. And then when you put them together in there, you really want this orientation to be in a vertical line, usually facing down. So I'll spin this guy around. You would put it in there like that so that it doesn't compress as it moves up and down inside the cylinder. So always replace those on a rebuild. For our intents and purposes, we're ready to lay out this engine and label all the parts. Okay, we have everything laid out and labeled. Let's pan down through here and look at what we have. We have our covered pole starter, our flywheel, our rear cover, which actually closed up the rear part of the crankcase. If we move through here, we then transition, we'll start. On this side we have our crankcase. It's got our main bearings in it. Our crankshaft is over here. On this other row we have our flywheel nut, ignition coil, magneto assembly, if you will, muffler, spark arrestor assembly. And now we'll take a look at the other row of items. For this one, we're going to really zoom in. So here we have our carburetor spacer and carburetor. There, it's a diaphragm style carburetor laying next to the spark plug. The 2-cycle cylinder, now remember that's not just a cylinder, but this one's the cylinder and the cylinder head. And because it's 2-stroke, it's got an intake port, exhaust port, and of course transfer ports. If we move right along, we have our piston ring, our connecting rod, our rod clip there, very small in the frame, our wrist pin, and don't forget that the connecting rod has needle type bearings for both your rod bearing and wrist pin bearing. There's another look at the crankshaft. If we move on the other side, you can see that we had our air cleaner cover with our kill switch on it, an air filter, foam filter element that you would clean and re-oil, our air cleaner cover. We got some fuel line, our dirty fuel filter in this engine, and gas cap, and that leads us back to our rear cover. Now, looking at the engine, the main bearings look good, the cylinder looked good, everything was spotless with this engine, and we know it did have good compression. And I also did a quick spark check on it, and it actually had spark. So what kept this engine from running? What did we really need to do to make this engine run? Clean out the carburetor and replace these broken fuel lines and maybe put on a new fuel filter, and we would have had a well-running engine that could have powered our string trimmer for many years to come. Let's wrap this up. Well, I hope you enjoyed this video today. You can see we laid out all of our parts. We really tried to be detailed as we took stuff apart and inspected it. I hope this answered some disassembly questions, maybe some component ID questions, and gives you a better understanding of how a 2-stroke engine operates. Namely, you can see that this engine design, well, it's a lot simpler than a 4-stroke. There's a lot of magic in the cylinder with the transfer ports, intake ports, etc., but there's no camshaft or valve train, valve springs. None of those other components are in the engine, so ultimately it makes the engine smaller, it makes it more compact and lighter, which makes it perfect for handheld power equipment and for other engines that need to be really light, high revving, and make good power. So I'm still a fan of 2-stroke engines. I hope after watching this video, you are too. Bye for now. Hope to see you in a future video.